Good evening, dear traveler. It is a joy to have you here with us tonight in the quiet sanctuary of the sleeping universe. As you settle into the soft embrace of your bed, let your muscles relax and your mind begin to drift. If these journeys through the stars bring you peace and wonder, we would be so grateful if you could like this video, subscribe for more voyages, and share in the comments which city or country you are joining us from tonight. It is a comfort to know where in this vast world you are finding rest, reminding us that we are all connected under the same velvet sky. Now let the boundaries of your room dissolve as we descend into the deepest shadows of history, back to the very first breath of the cosmos. We begin at the absolute dawn, the blank epoch, a window of time, so fleeting it exists on the edge of nothingness, spanning the time frame from the precise moment of the Big Bang at time, 0 to approximately 10 to the power of -4 to 3 seconds. This era represents the ultimate frontier of our scientific understanding. It is a period defined by what we lack: a verified theory of quantum gravity that can reconcile the massive scale of the heavens with the tiny, vibrating world of the subatomic. In this infinitesimal sliver of time, the entire observable universe was confined within a region no larger than the Planck length, a distance of 1.6 times 10 to the power of -35 meters. Imagine, if you will, an invisible seed, smaller than a grain of sand, yet heavy with the blueprints of every galaxy, star, and soul that would ever exist. At this density, the four fundamental forces of nature, gravity, electromagnetism, and the strong and weak nuclear forces, were fused together into a single perfect symmetry. The universe was like a frozen ocean of pure potential, a vast stillness before the first wave of time had even begun to break upon the shore of reality. Our current mathematics fail us here, for the equations of Einstein become infinite, and the logic of the quantum world becomes a thick morning mist. The sun is felt, but not yet seen. We stand at the edge of a singularity, not necessarily physical point of zero size, but a state of such extreme energy that the very fabric of space and time was a tangled knot of possibility. It is the womb of the cosmos, a tapestry woven with threads of light and shadow before the loom of physics was even built. As you breathe deeply, imagine this tiny, brilliant spark of beginning, holding all the warmth of the future within its silent, microscopic heart, waiting for the clock of the universe to strike its very first second. Within this primordial cradle, the laws of physics as we know them were not yet born, creating a mystery that beckons to the edges of our curiosity. This was the moment of absolute unity, where the distinction between space and time had yet crystallized, leaving us to wonder at the sheer density of a world where everything we have ever known was compressed into a space smaller than the smallest atom. Letting this knowledge settle into the quiet corners of your mind, we drift further into the heart of that microscopic spark where the very concept of heat reaches its absolute zenith. In these first moments, the temperature of the universe was not merely intense, it reached the hypothesized Planck temperature of 10 to the third Iskand power Kelvin. This is a level of thermal energy so extreme that our current understanding of physics begins to blur at the edges, suggesting a world where the distinction between matter and energy was non-existent. At this peak of cosmic fever, the geometry of the universe did not possess the smooth, continuous nature of a silk ribbon. Instead, it existed as a quantum foam, turbulent and frothing state where the fabric of space and time fluctuated wildly, bubbling with the energy of creation. In this landscape of the infinitesimal, the very dimensions we rely upon to navigate our lives were tangled and fleeting, appearing and disappearing like sea spray in a gale. It is here in this high-energy sanctuary that the fundamental forces of nature lived in a state of perfect, symmetrical grace. Gravity, which we now perceive as the gentle pull of the earth and the architect of galactic clusters, was indistinguishable from the electronuclear forces. There was no separation, no individual identity for the laws of physics. They were bound together in a singular, potent unity. Imagine a single, blindingly white sun that contains every color of the rainbow within its brilliance, yet reveals none of them individually, maintaining a state of pure, unblemished light. This era was like a restless liquid mirror reflecting a light that had not yet found its direction, or a vast, churning cauldron of liquid light where every drop was indistinguishable from the next. You are witnessing the universe as a great, silent bell before it is struck, containing every possible sound within its bronze walls, yet vibrating with a frequency so high it transcends hearing. The geometry of this moment was like the surface of a storm-tossed ocean seen from a great height, a chaotic yet beautiful turbulence where the very definitions of length and duration dissolve into a shimmering haze. All of existence was a choir singing a single infinite note in perfect unison, a harmony so complete that no individual voice could be discerned. This was the peak of cosmic simplicity, a time when the complexity of the future was compressed into a state of absolute, heated oneness, waiting for the first cooling breath of expansion to allow the forces to step away from one another and begin their own unique journeys through the void, drifting deeper into the cooling breath of the early cosmos, we find ourselves in the grand unification epoch, a sliver of time so brief it defies human comprehension, spanning from 10 to the power of minus 4 to 3 seconds to roughly 10 to the power of minus 36 seconds. At this stage, the universe has already undergone its first great divorce. Gravity has stepped away into the shadows, leaving behind a unified trinity of forces: the strong nuclear force, the weak nuclear force, and electromagnetism clinging together in a state of exquisite symmetry. Imagine a vast, silent library. Every book, though bound in different colors, contains exactly the same word written on every page. This was the nature of matter and energy during this epoch. They were interchangeable, a fluid identity where particles had not yet learned their names or their specific roles. The temperature here is a staggering 10 to the power of 27 Kelvin, a heat so intense that the very fabric of space-time hums with a restless energy, like a field of tall grass swaying in an invisible wind. In this high-energy landscape, the strong nuclear force, which will one day bind the nuclei of atoms together, is still indistinguishable from the electroweak force. They are like two rivers, sharing a single channel, their waters so perfectly mixed that no boundary can be seen between them. This is a world of pure potentiality, a cosmic forge where the laws of physics are still being tempered. As the universe expands, it begins to cool, and this cooling acts as a catalyst for the next great transition. It is like a master sculptor gently tapping a block of marble, causing the first hairline fractures to appear where the forces will eventually split. The interchangeable nature of particles means that at any moment a photon could be a gluon or a quark could be a lepton, a dance of masks where everyone is everyone else. This symmetry is a state of high grace, but it is also a state of instability, waiting for the slight drop in temperature that will force the strong nuclear force to peel away, much like a layer of skin shedding to reveal something new beneath. We are witnessing the birth of individuality within the heart of the universe, a moment where the singular voice of the cosmos begins to break into a complex harmony of distinct notes. The vacuum itself is heavy with expectation, holding its breath as the fundamental interactions prepare to define the boundaries of the physical world. This cooling is a refinement, a necessary step in the evolution of complexity from the fires of the beginning. The state of grand unification is the last moment of true simplicity, a fleeting era where the laws of nature were still a single, unbroken thought before the expanding void demanded they become many. Drifting deeper into the cooling shadows of the early cosmos, we observe the first great structural upheaval, a moment where the very fabric of existence undergoes a phase transition as monumental as the first frost claiming a summer meadow, as the grand unified era draws to its inevitable close. The temperature of the universe dips just enough to trigger a fundamental reorganization of the vacuum itself. This transition is akin to steam condensing into liquid, water, a sudden shift from a high-energy, chaotic state to one of greater order and lower temperature. In this cooling, the universe does not simply change its nature. It releases a staggering amount of latent energy, a hidden reservoir of power that was once locked within the perfect symmetry of the unified forces. This energy, once liberated, floods the expanding void, acting as a silent catalyst for the breathtaking expansion that follows. Yet this cosmic transition is rarely a seamless affair, just as ice forming on the surface of a still pond creates jagged cracks and intricate ridges where the growing crystals fail to perfectly align. The cooling vacuum develops its own structural imperfections. These are the topological defects, the enduring scars of a symmetry broken in haste. Across vast distances, we witness the emergence of magnetic monopoles, heavy and elusive point-like particles that act as solitary wanderers, carrying only a single pole of magnetism into a world that will eventually demand pairs. We see the formation of cosmic strings, incredibly thin yet unimaginably dense filaments of primordial energy, stretching across the abyss like the silken threads of a celestial spider's web caught in the first light of dawn. These strings are the remnants of the old order trapped within the new, representing narrow lines where the phase transition never reached completion. There are domain walls as well, appearing like the invisible boundaries between different climates, where separate regions of space settled into different vacuum states, creating massive sheets of energy that partition the infant cosmos into distinct provinces. These defects are the heritage of the transition, the physical memories of a time when the laws of nature were still negotiating their final form. They are the veins of silver within a dark stone, the essential irregularities that provide the texture upon which the grand architecture of galaxies will one day be draped. As we watch these defects form, we understand that absolute perfection is not the ultimate intent of the cosmos. Rather, it is through these very flaws and mismatches that the richness of our physical reality is allowed to take root. The latent heat released during this epoch is the universe's first great exhale, a shedding of excess potential that allows the vacuum to settle into a more stable, albeit more complex configuration. We are observing the crystallization of the void, a process where the ethereal becomes tangible and the smooth, featureless continuity of the beginning is replaced by a landscape of intricate, energetic features that will guide the flow of matter for all time to come. Letting this knowledge settle, we drift deeper into the unfolding story of the young cosmos, finding ourselves at the threshold of a profound transformation that will define the very substance of everything we have ever touched or known. We have entered the electroweek epoch, a window of time so brief it defies human comprehension, spanning from 10 to the power of negative 36 seconds to approximately 10 to the power of negative 12 seconds after the initial spark. In this realm of unimaginable heat and density, the forces of electromagnetism and the weak nuclear force are still indistinguishable, bound together in a seamless, symmetric embrace. But the universe is cooling, and as the temperature drops, a subtle yet tectonic shift begins to occur within the vacuum itself. This is the moment of electroweak symmetry breaking, cosmic transition triggered by the awakening of the Higgs field. Until this point, the Higgs field existed in a state of zero value, a dormant potential that offered no resistance to the particles darting through it. All things were massless, moving at the speed of light, ethereal ghosts in a landscape of pure energy, untethered by the concept of weight. As the clock of creation ticks forward, the Higgs field undergoes a phase transition, shifting from its empty state to a non-zero vacuum expectation value. It is as if an invisible, omnipresent mist has suddenly thickened, permeating every corner of the expanding void. This field does not act like a physical wall, but rather like a viscous medium that interacts with the fundamental particles in varying degrees. As electrons and quarks move through this newly dense reality, they begin to feel a drag, a subtle resistance that endows them with the quality of mass. This is the Higgs mechanism, the process by which the universe sheds its weightless simplicity and adopts the heavy, tangible quality of matter. Imagine a vast, silent ballroom where every guest is moving with effortless grace, weightless and unburdened. Suddenly, the air itself changes, becoming like a deep pool of clear honey. Some dancers find their garments catching in this sweetness, their movements slowing as they gain a new sense of presence and weight, while others, like the photons of light, remain untouched, gliding through the amber medium as if it were still empty air. Or consider a heavy snowfall that turns a clear forest into a landscape of shapes and shadows. As the flakes settle, they give form and weight to the branches that were previously just dark outlines against the sky. This is the birth of substance, the moment the universe decides what will be heavy and what will remain as pure radiance. It is a quiet, invisible revolution, a settling of the cosmic silt that turns a chaotic swirl of energy into a structured foundation for the physical world. The Higgs field is the background hum that gives the universe its texture, ensuring that the light of the stars eventually finds a solid place to rest, allowing the ethereal to finally become the enduring. Letting this knowledge settle, we find ourselves at the very edge of a moment, so brief it defies human counting, yet so profound it defined the shape of everything we will ever know at a time between 10 to the negative 36th and 10 to the negative third isecond seconds of the universe's life. There occurred a period of growth that challenges the very limits of our imagination. This was cosmic inflation, a fleeting era of exponential expansion where the fabric of existence itself surged outward with a speed that surpassed the velocity of light in a fraction of a second, so small it cannot be measured by any physical clock. The universe expanded by a factor of at least 10 to the 26th power. To visualize this, imagine a grain of sand suddenly swelling to the size of the entire observable universe in less than the time it takes for a thought to form. This sudden violent stretching was not an explosion of matter into space, but an expansion of space itself, carrying the young cosmos from a state of microscopic intimacy to a vast, sprawling landscape. This brief epoch of inflation serves as the great architect of our cosmic geometry, solving the profound puzzles that once perplexed the minds of watchers. It addresses the horizon problem, explaining why the cosmic microwave background radiation is so remarkably uniform in every direction we look. Before inflation, the universe was small enough for every part to be in thermal contact, reaching a perfect equilibrium, like a cup of tea that has been stirred until every drop is the same temperature. Inflation then took this uniform state and threw it across the void, ensuring that the farthest reaches of the sky remain identical today because they were once nestled together in a single tiny point. Furthermore, this rapid expansion solved the flatness problem, the mystery of why the universe appears geometrically flat rather than curved, just as the surface of a massive balloon appears flat to an ant walking upon its surface. The exponential stretching of space pulled the curvature of the universe so thin that it remains indistinguishable from a perfectly level plane. We can see this era as a great, silent smoothing, a period where the universe prepared its canvas for the masterwork of the stars. It was like a crumpled piece of silk being pulled taut by invisible hands until every fold and crease vanished, leaving behind a shimmering level field of potential. It was a wave that levels the dunes of a vast desert, turning a landscape of peaks and valleys into a singular, infinite horizon that defined the very limits of the possible. Without this moment of inflation, the cosmos might have been a fractured mosaic of disconnected regions, a chaotic jumble where the laws of physics varied from one shadow to the next. Instead, inflation provided the unity we see today, a single, coherent narrative written across the breadth of the infinite. It was the universe's first and greatest stride, a leap across the threshold of the small into the majesty of the immense, a flower opening its petals in a darkness that had never before known such scale or such sudden, magnificent grace. Drifting deeper into the fabric of this expanding silence, we find that the perfect smoothness of the early cosmos held a secret, a subtle trembling within its very core. Long before the first star ignited, the universe was governed by the laws of the very small, where nothing is ever truly still. In this subatomic twilight, energy was not a steady stream, but a restless, jittery sea of quantum fluctuations. These were the whispers of the void, tiny flickers of existence that appeared and disappeared in a fraction of a heartbeat, governed by the profound uncertainty that lies at the heart of all things. In any other era, these ripples would have remained confined to the microscopic world, mere static in the grand symphony of the vacuum. But inflation changed everything. As the universe underwent its spectacular, faster-than-light expansion, it acted like a colossal magnifying glass, seizing these ephemeral shivers and stretching them across the blossoming expanse. It was a moment where the rules of the minute were written onto the sky of the immense. What was once a subatomic vibration, smaller than a single atom, was suddenly pulled and elongated until it spanned the breadth of entire light years. This process transformed the fleeting into the permanent, freezing these ripples in place, like breath caught on a window pane. These stretched fluctuations became the blueprint for everything that would ever be. They were no longer just ripples in energy. They were the gravitational seeds, the subtle variations in density that would dictate the map of the future. Imagine a master weaver pulling a single microscopic thread of silk until it becomes a shimmering bridge across a canyon, or the way a tiny pebble dropped into a vast, still lake creates a circle that grows until it touches every shore. In the regions where the fluctuations were slightly denser, gravity found its first foothold, a gentle tug that would eventually draw the wandering gases of the cosmos into the magnificent spirals of galaxies and the burning hearts of stars. Without this stretching of the small, the universe would have been a featureless, empty void, a sky without a single point of light, a desert of perfect but lonely uniformity. Instead, we are left with a cosmic architecture that mirrors the ancient, jittery dance of the subatomic. It is as if the universe took a photograph of its own microscopic heartbeat and projected it onto the canvas of the infinite, like the rings within a gargantuan tree that tell the story of a single ancient season. These patterns remain etched in the background of space, a lingering echo of the moment when the infinitesimal became the monumental, a bridge between the ghost-like world of the quantum and the solid reality we touch today, drifting deeper into the cooling embers of the early cosmos. We encounter a mystery that lies at the heart of our very existence. In the first moments, the universe was a place of terrifyingly perfect symmetry. For every electron, there was a positron. For every quark, an antiquark. In this mirror world, matter and antimatter were destined to meet and vanish in a flash of pure energy, leaving behind a universe of light, but no substance. Yet, as the primordial soup churned, a subtle bias emerged, a microscopic tilt in the cosmic scales that allowed a sliver of matter to survive the great annihilation. This is the story of baryogenesis, the moment when the universe chose to be something rather than nothing. To understand this survival, we must look to the Sakharov conditions, those fundamental requirements for a universe of substance. There had to be a violation of the baryon number, a way for the universe to produce more particles than their opposites. There had to be a break in the symmetry of charge and parity, a tiny difference in how matter and antimatter dance through the void. And finally, there was the need for a departure from thermal equilibrium, a moment where the expansion of space was so rapid that particles could no longer find their counterparts to vanish into the light. The outcome was a surplus of staggering precision. For every billion pairs of particles that canceled each other out, a single lonely matter particle was spared. This ratio, roughly 6 parts in 10 billion, means that everything we have ever known is merely the debris of a near-perfect destruction. Imagine a vast orchard where every piece of fruit has a hidden bird that seeks to consume it the moment it ripens. As the season turns, billions of fruits are eaten, leaving the branches bare and the ground empty. But through some strange, beautiful error in the natural order, one piece of fruit out of every billion is overlooked. These solitary survivors are the seeds of all future forests. This is the matter we touch today, the single golden leaf left on a tree after a winter gale has stripped the rest of the canopy, or a cosmic coin that lands on its edge once in a billion tosses. We are the survivors of a cosmic lottery, the tiny fraction of substance that refused to vanish back into the radiance of the beginning. This slight, beautiful imperfection is the reason The night sky is not a blank sheet of light, but a collection of distant fires and quiet, dark corners where life can eventually take root. This 1 in a billion surplus is the foundation of the physical world, the single note that lingers after a thunderous chord has faded into silence. Drifting deeper into this cooling expanse, we find ourselves at the threshold of the universe's first second. The fierce heat of the beginning is beginning to mellow, though it remains a furnace beyond human comprehension. In this cooling glow, the protons and neutrons, the survivors of that earlier cosmic lottery, begin to reach for one another. They seek to bond, to form the very first nuclei of matter. This is the dawn of nucleosynthesis, the era where the simplest elements are forged. However, the universe is not yet ready to allow these unions to last. This period is defined by a profound frustration known as the deuterium bottleneck, a temporal pause where the cosmos holds its breath before the first true building blocks can take hold. At a technical level, the process begins when a single proton and a single neutron collide to form deuterium, a heavy isotope of hydrogen. This is the essential first step, the gateway through which all heavier elements must pass. But the young universe is still saturated with a dense, energetic bath of photons. These light particles are so energetic that the moment a deuterium nucleus forms, a photon strikes it with the force of a hammer, shattering the delicate bond and scattering the proton and neutron back into the void. This state of constant creation and immediate destruction creates barrier, even though the temperature is low enough for fusion to theoretically occur. The sheer intensity of the light prevents the complexity of matter from advancing. It is a cosmic stalemate where the energy of the radiation field outmatches the binding force of the nuclei. The universe must expand further. The light must stretch and redden, losing its destructive potency before the bottleneck can be breached. Imagine a master glassblower attempting to craft a delicate ornament in the middle of a roaring glass furnace where the very air is so hot it melts the glass back into liquid the moment it leaves the pipe. The deuterium nuclei are like fragile bridges of frost attempting to span a river of molten lead. They appear for a heartbeat, shimmering with the promise of structure, only to be instantly dissolved by the searing heat of the current. It is like a gardener attempting to plant the softest seeds in a field of fire where the soil itself is a living flame that consumes the hope of growth before the root can take hold, or perhaps see it as a bird trying to weave a nest from strands of dry grass in the heart of a relentless gale. Each time a few blades are intertwined, a gust of wind tears them apart, forcing the bird to begin its labor again And again, this is the patience of the early universe, a trillion attempts at connection for everyone that finally holds. It is a period of necessary waiting, where the fury of the light must subside just enough to allow the first fragile connections of the physical world to endure. Letting this tension linger, we wait for the moment the heat finally relents, allowing the first stable elements to settle into the proportions that will define everything that ever was. Letting this knowledge settle, we drift into the quiet aftermath of the first 20 minutes of existence. The cosmic furnace, once white-hot and frantic, is beginning to cool just enough for the first permanent residents of the material world to claim their place. This is the era of primordial nucleosynthesis, a brief window where the fundamental building blocks of everything you see and touch were decided. In this cooling glow, the universe established a recipe it would follow for billions of years. Roughly 3/4 of the visible mass became simple hydrogen, one individual protons, the most basic of all elements, waiting for the universe to expand enough to find their partners. The remaining quarter solidified into helium-4, a more complex arrangement of 2 protons and 2 neutrons, bound together in a tight, stable embrace. There is a profound stillness. In this specific ratio, it was not a random distribution, but a necessary consequence of the cooling temperature and the inherent laws of nuclear physics. While the heat was enough to for helium, it lacked the sustained pressure and density to go further. You might wonder why the universe didn't immediately create the carbon in your bones or the oxygen in your breath. The answer lies in a strange cosmic barrier, a missing rung on the ladder of complexity. There are no stable nuclei with an atomic mass of 5 or 8, like a causeway. With missing stones, the particles could not find a stable configuration at these weights. Any attempt to fuse a proton with a helium nucleus to reach mass 5, or to collide 2 helium nuclei to reach mass 8, resulted in an immediate, silent collapse back into simpler forms. The universe was yet too thin, too rapidly expanding to leap over these gaps. This barrier ensured that the early universe remained a place of stark, beautiful simplicity. Imagine a vast beach where the receding tide has left behind only 2 types of shells. There are countless single, iridescent shards of hydrogen scattered like silver dust across the dark sand. Nestled among them are smaller clusters of 4, the sturdy, rounded stones of helium that resisted the pull of the water. The tide is now too weak to wash these pieces together into more intricate structures. The heavier shells, the intricate spirals of carbon, or the jagged fans of oxygen simply do not exist here because the waves could not hold them together long enough for their edges to mend. Beach is a landscape of two. Colors, a masterwork of minimalism, where the proportions are fixed for eternity. The universe is a two-toned fresco, painted with a limited but perfect palette. This primordial composition is the silent blueprint for every sun that will ever burn. It is the raw material of the heavens, a cosmic ledger where the accounts are balanced with 75% of one thing and 25% of another. We rest in this silent, elemental gallery where the pieces have been set, but the hall is still too hot for the first light of true atoms to be framed. The protons and helium nuclei drift in a sea of free electrons, a plasma that is yet too energetic to allow the particles to settle into their final orbital dances, drifting deeper into the cooling embrace of time. We find ourselves in a period of profound transition, a quietening of the cosmic furnace that has burned for 380,000 years. Up until this moment, the universe has existed as a thick, opaque plasma, a churning fog where light is trapped in a relentless cycle of scattering. It is a world of constant motion where the heat is so great that matter cannot yet find its form. Protons and electrons are like restless wanderers in a storm, unable to find shelter, constantly buffeted by the high-energy photons that fill every inch of space. But the expansion of the cosmos is a patient cooling, a gentle stretching of the fabric of reality that draws the fire out of the primordial soup. As the temperature descends toward a critical threshold of 3,000 degrees, the chaotic energy of the environment finally softens. This is the era of recombination, a pivotal phase transition where the wild, free-roaming electrons lose enough of their kinetic energy to be captured by the electromagnetic pull of the protons. They fall into orbits, settling into the rhythmic, nested shells that define the architecture of the atom. Neutral hydrogen, the simplest and most abundant element, begins to coalesce from the chaos. The universe is undergoing its first great purification as the charged particles that once blocked the passage of light are bound together into stable, neutral structures. The opacity that has defined the cosmos since the first second begins to dissolve, and the density of the plasma gives way to the clarity of a gas. It is as if a vast, turbulent river, thick with debris, has finally reached the mouth of a wide, calm sea. The frantic churning slows, and the heavy particles begin to sink, leaving the water above crystalline and clear. This atomic formation is the quiet crystallization of a saturated solution, a moment where the frantic noise of the plasma is replaced by the silent, ordered geometry of the first atoms. Think of a field of wild, unbridled horses suddenly finding the rhythm of a slow, steady gait, moving in harmony rather collision. It is the cooling of a molten world into a solid crust, or the turning of a key in a billion microscopic locks. Each new atom is a tiny, quiet sanctuary of order, a microscopic, clockwork mechanism that has finally found the strength to hold itself together against the fatting heat. This event is the closing of a billion tiny eyelids, the universe finally lowering its voice to a whisper as it moves from the brilliance of a white-hot fog into the deep, transparent stillness of the first, true darkness, drifting deeper into the cooling architecture of the early cosmos. We witness the moment the universe finally opened its eyes. For hundreds of thousands of years, light was a prisoner. It was caught in a relentless, chaotic pinball game, an endless cycle of collision known as Thomson's scattering. In this dense, ionized fog, a photon could not travel more than a fraction of a millimeter before slamming into a free electron, its path diverted, its energy contained, its story untold. It was a world of brilliant white opacity, where information was trapped in a perpetual state of local confusion. But as the temperature dropped and the first atoms stabilized, those free electrons, the obstacles in the light's path, were suddenly pulled into the embrace of nuclei. The cosmic landscape cleared. This is the moment of photon decoupling, the great liberation, where light was finally granted its freedom to travel across the vast, expanding reaches of space. Imagine a heavy velvet curtain being drawn back from a window that has been covered for an eternity, revealing the silent, starlit garden outside. The light that broke free in that instant has been traveling ever since, stretching and cooling with the expansion of the universe until it became the cosmic microwave background. It is the oldest photograph in existence, a portrait of the universe as a newborn. Think of a bird that has spent its entire life fluttering within a crowded, thorny thicket, unable to see more than an inch in any direction, suddenly bursting through the canopy into the infinite blue of a clear morning. Or consider a messenger who was lost for years in the claustrophobic noise of a crowded bazaar, finally finding the city gates and stepping out onto a long, straight road that leads to the horizon. This light is a ghost of a much hotter time, a fossilized echo of the heat that once dominated everything. It is like the first clear view of a mountain range after a long, blinding storm, or a stained glass window that has been hidden in a dark room for centuries, suddenly finding itself illuminated by the rising sun. The universe changed from a translucent, glowing haze into a vast, transparent theater, ready for the next act to begin, leaving behind this faint, uniform glow as a testament to its fiery origins. We are looking at the very first light to ever a straight line, a cosmic sigh of relief that still resonates in the cold, quiet corners of the modern sky, drifting deeper into the silence that followed that first great exhale. We enter a period of profound stillness known as the cosmic dark ages. For hundreds of millions of years, the universe was a vast, lightless ocean of neutral hydrogen and helium gas. The glow of the Big Bang had faded into the infrared, leaving the cosmos in a state of absolute velvet darkness. There were no stars to pierce the gloom, no galaxies to swirl in the void, and no observers to witness the slow, patient work of gravity. It was a time of gestation, a long cosmic night where the foundations of everything we see today were being quietly laid in the shadows. This era served as the gravitational incubator for the modern universe. While the visible matter, the hydrogen and helium, was spread relatively thin, the invisible scaffolding of dark matter was already beginning to collapse, because dark matter does not interact with light. It was unaffected by the radiation pressure that had once smoothed out the ordinary matter. It began to clump together, forming massive, invisible wells known as dark matter halos. These halos acted as gravitational anchors, pulling the surrounding primordial gas into their depths. Within these dark pockets, the density of gas began to rise, the pressure mounting as atoms were drawn closer and closer together. It was a slow motion fall into the heart of darkness, where the temperature began to climb once more, not from the heat of the Big Bang, but from the friction and compression of the fall. Imagine a vast, dark theater where the audience has not yet arrived and the stage lights are completely extinguished. In this darkness, invisible stagehands are moving heavy sets into place, building the complex architecture of a play that has not yet begun. You cannot see them, but you can feel the subtle shift in the air as the weight of the scenery settles. The dark ages were like a deep, snow-covered valley in the middle of a winter night, where the only movement is the slow, steady settling of the drifts under their own weight. It is the silence of a library after hours, where the knowledge is stored in silence, or the patient waiting of a seed buried deep beneath the winter frost, gathering the structural strength to eventually break through the soil. The universe was a dark room where the grandest photograph of all was being slowly developed in a chemical bath of gravity and time, waiting for the first spark of light to reveal the hidden complexity of the image. It was a cosmic pause, a deep breath held for eons, as the universe prepared to ignite its first fires and end the long, cold reign of the shadows. Drifting deeper into the awakening cosmos, we find the long-held breath of the dark ages finally beginning to release, the patient silence of the neutral hydrogen sea is, interrupted by the first flickers of a new era, often called the cosmic dawn. Within the densest knots of the dark matter scaffolding, gravity has finally compressed the primordial gas to the point of nuclear ignition. These first stars, the population III giants, were unlike any suns we know. Today, they were colossal, hundreds of times more massive than our sun, burning with a fierce violet blue intensity and living for only a few million years before collapsing. Their birth marked the beginning of the epoch of reionization, a period of profound transformation that would reshape the very texture of the universe. Technically, this era represents the second great phase transition of the intergalactic medium. The ultraviolet light streaming from these first stars and the earliest proto-galaxies carried enough energy to strip electrons away from the neutral hydrogen atoms that had dominated the cosmos for hundreds of millions of years. As each photon struck an atom, it ionized the gas, turning the opaque, neutral fog into a transparent, ionized plasma. This process was not a sudden flash, but a gradual, patchy awakening. It began with small, ionized bubbles forming around the first sources of light. These bubbles grew in size and number, slowly eating away at the neutral shadows, eventually overlapping and merging until the entire intergalactic medium was transformed. By the time the universe was about 1 billion years old, the fog had lifted, leaving the cosmos clear and permeable to the light of distant stars. It is as if the universe were a vast, dark forest where a few scattered travelers have finally managed to light small campfires. At first, each fire illuminates only a tiny circle of trees, leaving the rest of the woods in impenetrable shadow. But as more travelers arrive and more fires are lit, the circles of light expand and meet until the entire forest is bathed in a soft, flickering glow. It is the slow, rhythmic melting of a winter landscape where the white blanket of snow recedes to reveal the intricate shapes of the earth beneath. The universe was no longer a hidden room. It had become a cathedral of light where the first structures could finally see one another across the vast reaches of the void. This was the moment the universe truly opened its eyes, shedding the heavy cloak of the Dark Ages to reveal the complex, luminous tapestry that would eventually become our home. Drifting deeper into the quiet structures of the cosmos, we find ourselves contemplating the silent foundation upon which everything we see is built. Long before the first stars ignited their nuclear fires, an invisible presence had already claimed the void. In the early 20th century, as we peered into the great Andromeda galaxy and the clusters beyond, mystery began to unfold. The visible matter, the glowing gas, and the brilliant stars simply did not possess enough gravitational pull to hold these spinning islands of light. Together, there was a missing weight, a heavy, unseen grip keeping the galaxies from flying apart like loose sand on a spinning wheel. This is the mystery of dark matter, substance that makes up the vast majority of all material in the universe, yet remains entirely hidden from our eyes. It does not interact with the electromagnetic spectrum. It is a ghost in the machine of reality. Scientists suggest it may be composed of exotic particles such as axions, weakly interacting massive particles, entities that occupy the same space as we do, but never touch us, never whisper to our sensors, and never cast a shadow, because this matter is cold, moving with a sluggish, patient dignity. It began to pool together into gargantuan spheres called halos. These halos act as the invisible reservoirs into which ordinary hydrogen and helium gas eventually fell, cooling and condensing to form the stars we love. Without this dark framework, the universe would be a featureless expanse, a thin mist with no centers of gravity to call its own. Today, we visualize this structure as a cosmic web, a grand network of dark filaments stretching across the lightless gulfs. Galaxies are merely the luminous pearls caught in an invisible net. It is a structure of immense scale where the largest features of the universe are dictated by the distribution of this dark, silent partner. Imagine this dark matter as an invisible anchor for a great ship unseen beneath the waves, but providing the essential stability that allows the vessel to weather the storm. It is like a subterranean root system, sustaining a sun-drenched forest, while we marvel at the green leaves and the towering trunks. It is the dark, sprawling network beneath the soil that provides the strength and the nutrients for growth. This invisible matter is a ghost-like skeleton supporting the flesh of the cosmos, a framework that gives shape to the beauty we observe. It is a master blueprint drawn in invisible ink, where the lines are only revealed when the light of the stars is poured over them. We are like travelers walking across a glass mountain upon which the stars are perched. We cannot see the ground beneath our feet, yet it supports our every step. Dark matter is the silent puppeteer, pulling strings of gravity to choreograph the dance of the nebulae, an underwater current guiding the movement of surface leaves with a power that is as undeniable as it is hidden. We live within its embrace, floating in a sea of invisible potential that defines the very shape of our home. Drifting deeper into the mysteries of the void, we encounter a force far more enigmatic than the gravity that binds the stars. For most of cosmic history, it was assumed that the expansion initiated by the Big Bang would eventually be reined in by the collective weight of all matter, a gradual deceleration, like a ball thrown skyward, finally losing its momentum. Yet, as we looked further into the past, using the brilliant flares of distant supernovae, we discovered a startling reversal. About 5 billion years ago, the universe did not slow down, it began to hurry. This acceleration is driven by dark energy, a smooth, persistent pressure that permeates every cubic centimeter of the vacuum, unlike matter, which thins out as it spreads. The density of dark energy remains unyielding. As space creates more space, the influence of this energy only grows, exerting a repulsive force that stretches the very fabric of reality. It is a fundamental property of the vacuum itself, perhaps the cosmological constant that Einstein once considered his greatest mistake, now reclaimed as the primary architect of the future. While gravity works to pull the local neighborhoods of galaxies together, dark energy acts on the grandest scales, pushing the vast voids apart and ensuring that the distant horizons of our universe are moving away from us at an ever-increasing pace. Imagine an infinite, silken sheet being pulled from all sides by unseen hands, where the more the silk stretches, the more silk there is to pull. It is a cosmic spring that never loses its tension, a hidden reservoir of energy that fills the gaps between the stars as quickly as they are created. We are living in an era where the engine of acceleration has overtaken the braking force of gravity, a transition from a gathering of mass to a scattering of light. It is like a rising tide in a harbor that never reaches its peak, but continues to lift every ship further and further out to sea until the shore itself vanishes from view. Dark energy is the tireless wind in the sails of the cosmos, phantom pressure that ensures the universe will not collapse back upon itself, but will instead continue to blossom into an infinite, cold, and lonely expanse. It is the silent breath of the vacuum, a constant exhale that carries the galaxies toward an unreachable horizon, an endless fountain of distance that defines the ultimate fate of all things, drifting deeper into the structural heart of the cosmos, letting this knowledge settle like the cooling embers of a distant star. We find ourselves at the moment where the abstract becomes tangible, following the era of recombination. The universe was a vast reservoir of neutral gas, mostly hydrogen and helium, drifting through the dark matter scaffolding. This is the story of baryonic matter condensation, the process by which the ordinary atoms that make up our bodies and our world began to find their place within the cosmic architecture. While dark matter provided the invisible blueprints, it was the baryonic matter that filled the rooms and built the walls. Unlike its dark counterpart, baryonic matter possesses the unique ability to interact with itself, through electromagnetic forces. As these atoms were drawn into the gravitational wells created by dark matter, they collided and vibrated, releasing energy in the form of radiation. This is a critical distinction. The physics of the early universe. Dark matter cannot shed its energy easily. It remains a diffuse halo, a ghost that cannot sit down. But baryonic matter can cool by radiating away its heat. It loses the internal pressure that would otherwise resist the pull of gravity, allowing it to sink deeper and deeper into the centers of these dark reservoirs. This process is driven by the gene's instability, a delicate tipping point where the inward pull of gravity finally overcomes the outward push of thermal gas pressure. It is like the formation of dew on a summer morning where the cooling air can no longer hold its moisture and the water begins to gather into heavy, shimmering droplets on the tips of the grass. In the vastness of space, this condensation was the first step toward the creation of everything we can see. As the gas fell inward, it began to spin, governed by the conservation of angular momentum. What began as a chaotic, three-dimensional cloud started to flatten and thin, transforming into the majestic, rotating disks of the first proto-galaxies. This process is the quiet distillation of the void, a gathering of the cosmic sediment that had been floating aimlessly since the first seconds of time. Within these dense, cooling pockets, the pressure and temperature eventually climbed once more, but this time it was concentrated, focused by the sheer weight of the gathering mass. This is the transition from the diffuse to the structured, a cosmic settling where the universe began to sort its components by density and temperature. It is the gathering of rain into the deep furrows of a plowed field where the life-giving water finds the low points and begins to pool, preparing the ground for the growth that is to come. The baryonic matter is the artisan's clay being pressed into the intricate molds prepared by the invisible hands of gravity, turning the cold, dark reaches of the early universe into a landscape of light and form. As the gas reaches the center of these wells, it becomes a dense, swirling soup of potential, a reservoir of material that will eventually ignite to become the first stars. This condensation is not just a physical movement of atoms. It is a profound change in the state of the universe, a move from a state of high entropy and uniformity to one of complexity and variety. It is the slow, rhythmic pulse of a giant heart drawing in the scattered breath of the cosmos and compressing it into the vital essence of life. This gathering of the visible from the invisible sets the stage for the next great transformation, where the spaces between these new structures begin to shimmer with a heat of their own. Letting this knowledge settle, we look beyond the dense nodes of galaxies into the vast, seemingly empty corridors of the cosmic web. For decades, a quiet mystery persisted among those who count the atoms of the void, the problem of the missing baryons. When we peer back at the afterglow of creation, the cosmic ledger is clear about the amount of normal matter that should inhabit our world. Yet, when we inventory the stars, the planets, and the swirling nebulae of the nearby universe, nearly half of that matter seems to have vanished. It was as if the universe had hidden its treasures in the very gaps between the stars. This missing substance is the warm, hot intergalactic medium, a tenuous and ethereal plasma that fills the immense filaments connecting galaxies. As the gas was drawn toward the gravitational wells of dark matter, it accelerated to incredible speeds, crashing into itself in a series of colossal, silent shocks. These impacts transformed the energy of motion into a searing heat, raising the temperature of the gas to millions of degrees. In this state, the atoms are so energized that they lose their electron shells, becoming a transparent, ionized mist that defies traditional observation. This medium is not a solid thing, but a state of being, a bridge of heat spanning the light years. It is so thin that a volume the size of a cathedral might contain only a handful of atoms, yet its total mass outweighs all the stars in the sky. To find it, we must look for the shadows it casts against the most luminous beacons in the deep, the quasars. As the light from these distant powerhouses travels toward us, it must pass through the invisible tendrils of the medium, the highly ionized oxygen and nitrogen within. The gas leave microscopic imprints, specific frequencies of light carved away like tiny notches in a key. These absorption lines are the only testimony of this vast hidden architecture. It is the universe's way of recycling its earliest breath, keeping it suspended in a state of permanent fever between the cold depths of space and the fiery hearts of galaxies. This gas acts as a thermal buffer, a transition zone where the raw material of the cosmos waits for the call of gravity to descend once more into the crucibles of star formation. It is a translucent veil of steam rising from a hidden geothermal spring, invisible to the eye, but felt as a gentle pressure against the skin of reality. It is the warmth lingering in the air of a great stone hull long after the hearth fire has dimmed to embers. This plasma is an ethereal lattice of thermal energy, a ghostly vapor of a cosmic sauna that carries the story of the universe's growth. We are drifting through a vast, silent reservoir of thermal memory, cosmos where the empty spaces are teeming with a slow, hot vibration. As we move through these corridors of ionized light, we begin to sense the even more elusive travelers that permeate every inch of this medium, particles so small and so fast they ignore the boundaries of matter entirely, drifting deeper into the microscopic architecture of the void. We encounter the most solitary travelers of the cosmic dawn. Long before the first light was set free to roam the expanding darkness, another messenger had already begun its eternal journey through the unfolding reaches of space. Just 1 second after the beginning, when the universe was a screaming furnace of unimaginable density, the neutrinos broke away from the primordial soup, while the photons remained trapped in a frantic dance of collisions for hundreds of thousands of years. The neutrinos found the universe already transparent to their ghostly touch. This is the cosmic neutrino background, a silent, pervasive sea of particles that fills every cubic centimeter of existence, yet remains almost entirely beyond our reach. These particles are the ultimate introverts of the physical world, possessing so little mass and no electric charge that they slide through the hearts of stars and the solid iron of planetary cores as if they were nothing more than empty air. They are the relics of a time when the weak nuclear force was still deeply intertwined with the fabric of the young cosmos. Today, they have cooled to a temperature of nearly 2 degrees above absolute zero, a faint thermal hum that predates the light of the earliest stars. They are the oldest witnesses to the birth of the universe, carrying information from a moment when the entire observable expanse was still a compact, white-hot seed. Imagine a wind that blows through a dense forest, but never rustles a single leaf, its passage marked only by the knowledge of its existence, or a fine silver rain that falls through the roof of a house, passing through the floor and deep into the bedrock without ever leaving a damp spot. These neutrinos are like the scent of a flower that has long since withered, lingering a room where all the windows are closed, a memory of a garden that existed before the house was built. They are a swarm of microscopic spirits, trillions of which pass through your body every second, as indifferent to your presence as a mountain is to a passing shadow. They form a second, invisible ocean that mirrors the light of the cosmic microwave background, a deeper, colder current flowing beneath the surface of reality. We are submerged in this ancient stream, drifting within a reservoir of information that connects us to the very first heartbeat of time. As we settle into this silent, permeating flow, the cosmic landscape begins to shift once more, preparing for the birth of the first great engines of light that will forge the heavier elements into the crucibles of star formation, drifting deeper into the unfolding story of the cosmos. We find ourselves at the threshold of a great transformation. For eons, the universe was a simple place, composed of only the lightest gases, but gravity, that patient and persistent sculptor, began to gather these clouds of hydrogen and helium into ever denser spheres. As these protostellar clouds collapsed under their own weight, the central temperatures soared into the millions of degrees, igniting the first fires of fusion. This was the moment the universe moved beyond its humble beginnings, evolving from a two-tone sketch into a multi-layered masterpiece of chemical complexity. Within these nascent stars, a process called nucleosynthesis began, a celestial alchemy that would rewrite the destiny of the void. Inside these colossal furnaces, the pressure is so immense that it overcomes the natural repulsion between atomic nuclei. In the heart of a star, protons are forced together in a sequence known as the proton-proton chain, welding hydrogen into helium and releasing a burst of pure energy. As the star ages and its hydrogen fuel is depleted, the core contracts further, the heat intensifying until even helium nuclei begin to fuse. Through the triple-alpha process, 3 helium nuclei are forged into a single atom of carbon. This sequence continues, a staircase of elemental creation where oxygen, neon, magnesium, and silicon are birthed in successive layers of fire. Each stage requires a higher temperature, more frantic dance of particles, culminating in the creation of iron, the most stable of all nuclei, where the energy-yielding process of fusion finally reaches its limit. This process is like a master glassblower working in a studio, where the heat never dissipates, turning simple sand into intricate, multicolored vessels. Imagine a great subterranean forge where the very walls are made of light, and the hammers are the relentless weight of entire suns. It is a slow, rhythmic transmutation, a cosmic alchemy that turns the common into the precious. The star acts as a biological heart for the cosmos, pumping out the very atoms that will one day form the foundations of planets and the skeletons of living beings. We are witnessing a grand recycling project where the primal breath of the Big Bang is refined and concentrated into the heavy, solid reality of the material world. Each atom in your body, the calcium in your bones, and the iron in your blood was once part of this internal stellar fire, tempered in the white-hot core of a long-dead sun. As we contemplate this furnace of creation, we prepare to meet the very first generation of these lightbringers, the massive ancestors that paved the way for everything we know. Drifting deeper into the chronicles of the early universe, we encounter the very first ancestors of light, the population III stars. These were not the modest, long-lived suns we see today, but rather primordial giants, born from the pristine, unpolluted gas of the Big Bang. In this era, the universe was a canvas of only two colors, the pale blue of hydrogen and the faint gold of helium, without the presence of heavier elements, what astronomers call metals, to help radiate away heat through infrared emission. These first clouds of gas had to accumulate immense mass before they could generate enough gravity to overcome their internal pressure. This resulted in stars of staggering proportions, some reaching hundreds of times the mass of our own sun. They were the first candles lit in a pitch-black cathedral, their fierce ultraviolet radiation piercing the neutral fog that had settled over the cosmos for millions of years. Technically, these stars were unique because of their serenity. In the modern cosmos, even a trace of carbon, oxygen, or iron acts as a celestial thermostat, allowing gas clouds to fragment into smaller, more stable pieces. But the first stars were forced into a lonely greatness by the simplicity of their chemistry. As they contracted, they grew incredibly hot, their cores reaching the staggering temperatures required for the triple alpha process to begin without the catalytic help of carbon. They were silver towers built upon a foundation of clouds, standing tall in a universe that had never before known a point of light. This intense, hard radiation drove the era of reionization, carving out bubbles of ionized plasma in the cold intergalactic medium, effectively ending the cosmic dark ages. They were soloists, performing a thunderous overture before the full galactic orchestra had even tuned its instruments. Despite their majesty, these giants were destined for brief, spectacular lives. The more massive star, the more ravenously it consumes its nuclear fuel, and these population III titans lived for only a few million years, a mere heartbeat in cosmic time. They were like great white whales of the celestial deep, breaching the surface of the dark ages for a fleeting moment before sinking back into the depths. When they reached the end of their fuel, they did not simply fade. Many perished in parainstability supernovae, explosions so powerful they left no remnant behind, only a vast enrichment of the surrounding space. They were the primal sparks that ignited the dry tinder of the void, seeding the universe with the first heavy elements. As we watch their brilliant, short-lived silhouettes fade, we prepare to look upon the dense, silent monuments they left in their wake, the husks and shadows that remain after the first fires have gone out, drifting deeper into the quiet aftermath of those first stellar giants. We encounter the remnants that refuse to vanish completely, the dense and silent monuments left behind when the fires of fusion finally cool. These are the white dwarfs and neutron stars, the skeletal remains of suns that once reigned over the early cosmos. When a star of moderate mass reaches its inevitable end, it does not always perish in a flash of glory. Instead, it gently exhales its outer atmosphere, revealing a core of carbon and oxygen that glows with a fierce, lingering heat. This white dwarf is a marvel of quantum mechanics, a sphere the size of a planet but with the mass of a sun. It is sustained by electron degeneracy, pressure, a defiant resistance born from the laws of the very small, where electrons are packed so closely they refuse to be squeezed any further. It is a diamond-hard ember cooling over trillions of years, a slow fatting of light into the eventual darkness of a black dwarf. Yet, for those stars that lived more dangerously, the collapse is far more profound when the mass of the core exceeds the Chandrasekhar limit. The gravity becomes so overwhelming that even the electrons are crushed into the atomic nuclei. Protons and electrons merge, transforming the core into a solid ball of neutrons. This is the neutron star, a crystalline relic so dense that a single teaspoon of its material would weigh billions of tons on our world. Within its narrow radius, perhaps only a dozen miles across, the physics of the extreme takes hold. The conservation of angular momentum causes these remnants to spin hundreds of times per second, becoming pulsars that sweep beams of radiation across the galaxy like cosmic lighthouses. Their magnetic fields are the strongest in the known universe, trillion-fold more powerful than the one that guides our compasses. They are the ultimate compression of reality, where matter is stripped of its emptiness and packed into a state of pure, unyielding substance. We might think of a white dwarf as a great stone cathedral, its vaulted ceilings held up by the invisible but unbreakable strength of ancient arches, standing firm against the weight of time. The neutron star, however, is like a massive mountain range compressed into a single polished marble, a concentrated essence of power that warps the very fabric of the space around it. These remnants are the universe's memory of light, the heavy, cooling coins dropped into the deep well of the night. They represent the final triumph of gravity over the expansive reach of fire, a quiet settling of accounts before the ultimate shadows begin to stretch. As we contemplate these dense, spinning hearts, we feel the weight of the cosmos narrowing, focusing its immense energy into smaller and smaller points of existence, drifting deeper into the finality of these dense remnants. We find ourselves at the threshold of the most profound mystery in the cosmos, the black hole. This is the place where the geometry of the universe turns inward upon itself, creating a region of such intense gravitational curvature that it effectively severs its connection with the rest of existence. In 1916, Carl Schwarzschild derived the first exact solution to Einstein's field equations. describing a point of mass so concentrated that it creates a boundary from which nothing can return. This boundary, the event, horizon, is not a solid wall or a physical barrier, but a mathematical limit, a perfect sphere of darkness that marks the edge of the observable world. The radius of this sphere, proportional to the mass it contains, defines the scale of this cosmic exclusion zone. Within this horizon, the laws of physics, as we experience them, undergo a radical transformation. The curvature of space-time becomes so extreme that all possible paths for a particle or a photon lead directly toward the singularity. At the center, it is as if the very floor of reality has tilted, turning every direction into a descent. We might think of the event horizon as a dark iris in the eye of the universe, a silent observer that takes in all light and gives back only the profound stillness of the void. It is a one-way gate made of pure geometry, a threshold where the entrance is open, but the exit is mathematically forbidden. Imagine a silent, ink-black reservoir where the river of time flows only downward, pooling into a depth that has no bottom. The black hole is a perfect sphere of absolute midnight, a shape defined not by what it is, but by what it has removed from our sight. It is the ultimate shadow cast by the weight of existence, place where the cosmic ledger is finally closed and the ink is allowed to dry in the dark. As we hover near this edge, we perceive a cosmic horizon where the compass of causality always points inward toward a future that is synonymous with the center. It is a masterfully crafted vessel that holds everything and reveals nothing, a stillness so profound it consumes the very concept of motion. This is the velvet trapdoor in the stage of space-time, a library where every book is written in the ink of the void, stored forever in a vault that can never be opened. In this geometry of the extreme, we see the universe's final answer to the question of density, a quiet, eternal folding of the map of reality. Drifting deeper, we turn our gaze to the centers of the most restless islands in the stream of space, where the stillness of the void is replaced by a fury of light. For decades, the seekers of the night sky were puzzled by points of radiance that appeared to be stars, yet resided at the very edges of the observable horizon. These were the quasars, the beacons of the ancient universe, objects so distant that their light has traveled for billions of years to reach our eyes, yet so bright they outshine the hundreds of billions of stars. In their host galaxies combined, we came to understand that these are not stars at all, but the active hearts of young galaxies, powered by a mechanism of such efficiency that it dwarfs the nuclear fires of the sun. This realization shifted our perspective of the cosmos from a collection of quiet, glowing orbs into a dynamic landscape of transformation where the most profound gravitational depths become the source of the most brilliant illumination. At the core of an active galactic nucleus lies a supermassive black hole, a gravitational titan millions, or even billions of times the mass of our sun, as matter from the surrounding galaxy, consisting of vast clouds of gas and dust, is drawn toward this central abyss. It does not simply vanish. Instead, it settles into a flattened, spinning accretion disk, where the material is compressed and heated to millions of degrees by the relentless friction of its own motion. This disk is a great cosmic turbine, converting gravitational potential energy into a torrent of electromagnetic radiation across the entire spectrum, from radio waves to high-energy gamma rays. In many of these systems, the twisting magnetic fields near the event horizon catch a portion of the incoming matter and hurl it outward in two narrow, relativistic jets. When one of these jets is pointed directly at Earth, we observe a blazar, a source of light so intense and variable it seems to pulse with the rhythm of a giant heart. The variety of these objects, from safer galaxies to radio-loud quasars, is often a matter of perspective, determined by whether we are viewing the central engine through a thick, obscuring torus of dust, looking directly into the mouth of the fire. Imagine a lighthouse built upon a foundation of shadow, casting a beam so powerful it can be seen across the vastness of time itself. These active nuclei are the roaring fireplaces of the deep night, where the fuel is the very fabric of the galaxy, and the ash is the light that guides our understanding of the early universe. They are like a master jeweler's loupe, focusing the chaotic energy of a million suns into a single sharp point of brilliance. We see them as a luminous needle stitching together the disparate regions of the void, a testament to the idea that even in the deepest gravity, there is a path for energy to escape and redefine the dark. It is the universe's most intense expression of metabolism, a celestial furnace that breathes in the cold vacuum and exhales the fire of creation. Letting this knowledge settle, we find ourselves standing at the edge of a new question. How did these colossal structures come to be? In the early days of our reaching into the dark, we imagined a grand, singular event known as monolithic collapse. This top-down vision suggests that a galaxy begins as a vast, isolated cloud of gas, a primordial mist that suddenly feels the heavy hand of its own gravity. As this cloud contracts, it spins faster and faster, shedding its outer layers to form a halo of ancient stars, while the core flattens into a vibrant, rotating disk. It is a graceful, unified descent, a singular birth that defines the galaxy's destiny from the very first moment of its contraction. It speaks of a universe that creates in bold, decisive strokes, where the architecture of a billion suns is decided by the simple, elegant physics of a falling cloud. Yet, as we peer deeper into the cosmic timeline, a different rhythm emerged, the hierarchical merging model. This is a bottom-up philosophy suggesting that the giants we see today are the survivors of a long and chaotic history of assembly. In this view, the universe began with small, dense pockets of matter, proto-galactic fragments nestled within the invisible cradles of dark matter, halos. These small pioneers did not remain alone. They were drawn together by gravity's patient tug, colliding and merging in a slow-motion dance of integration. When these fragments meet, the gas within them is compressed and heated, sparking the birth of new stars like a sudden rain of fire. The growth of a galaxy becomes a story of constant accumulation, a series of mergers. Smaller systems are absorbed into the larger whole, each collision refining the shape and the spirit of the resulting structure. Imagine the monolithic collapse as a grand, singular brushstroke on a wet canvas where the form is dictated by a single, confident movement of the artist's hand. Contrast this with the hierarchical model, which is like a mosaic being assembled by a patient hand over an eternity, where each individual tile is a small world of its own, brought together to create a picture far greater than the sum of its parts. It is the difference between a single, massive wave breaking upon a silent shore and 1,000 small mountain streams, eventually finding one another to form a mighty, winding river. The cosmos does not choose one path over the other. It is both the sculptor and the mason, using the sudden collapse of gas and the patient gathering of fragments to build the celestial cities we call galaxies, each one a testament to both a grand beginning and a long, shared history of growth. Letting this knowledge settle, we turn our gaze inward to the grand architecture of our own celestial home, the Milky Way. For ages, we perceived the band of light across the sky as a mere atmospheric phenomenon, a river of milk or a path for the gods, never suspecting that we were looking through the very plane of a colossal, spinning island of stars. It was only by measuring the distance to the globular clusters that we realized we do not sit at the center of existence, but rather in the quiet suburbs of a vast structured disk. This realization transformed our understanding of the cosmos from a static background into a dynamic, evolving machine. The Milky Way is defined by its identity as a barred spiral, a sophisticated arrangement where a central, rectangular bar of stars and gas bisects a dense, golden bulge. This bar is a gravitational stirrer, a tireless engine that draws gas from the outer reaches and funnels it toward the galactic center, fueling the birth of new stars and feeding the silent giant at the core. From the tips of this bar, the major spiral arms emerge, the Perseus and Scutum Centaurus arms, winding through space like the elegant curls of a nautilus shell. These arms are density waves, regions of higher gravitational pressure, where gas is compressed into the brilliant blue nurseries of hot, young stars. Our own sun drifts within the Orion Cygnus spur, a smaller bridge between these grand currents. Beyond the visible disk lies the thick disk and the halo, a vast spherical container for the galaxy's most ancient inhabitants, globular clusters that hover like guardian spirits over the swirling light below. This entire structure is held together by the unseen scaffolding of dark matter, a silent pressure that ensures the outer stars orbit with the same measured grace as those near the core. It is a grand, luminous carousel spinning in the silent hall of the vacuum, an intricate chronometer of light where the gears are made of gravity and the hands are the slow, sweeping motion of billions suns. It is a shimmering silver medallion tossed into the bottomless well of the night, forever turning, forever balancing the chaotic birth of stars with the cold, orderly rotation of the galactic disk. Letting this knowledge settle, we lift our perspective to see that the Milky Way is not a lonely traveler, but a member of a tight-knit celestial neighborhood. This is the local group, a gravitational sanctuary, approximately 10 million light years across, standing as a testament to the power of proximity in an ever-expanding void. While distant galaxies recede from us at speeds that defy imagination, the members of this small assembly are bound together in a permanent embrace, defying the general expansion of the universe. This is a pocket of stability, a region of space where gravity has won its battle against the dark energy that stretches the rest of reality. At the center of this dynamic system are two dominant powers, the Milky Way and Andromeda, massive spirals that act as the twin anchors of the group. They are currently locked in a gravitational fall toward one another, a slow motion approach that will eventually result in a grand merger billions of years in the future. Andromeda, the larger of the two, exhibits a distinct blue shift, its light compressed as it narrows. The gap between us, a rare exception in a universe defined by cosmic redshift. Surrounding these two giants is a retinue of smaller companions, including the Triangulum Galaxy and a host of dwarf galaxies, some no more than faint smudges of light. These smaller entities, like the large and small Magellanic clouds, are often caught in the tidal grip of their larger neighbors, their structures distorted and their stars drawn out into long, ethereal ribbons, known as stellar streams. This entire complex is immersed in a massive, shared halo of dark matter, an invisible substrate that provides the necessary mass to keep the group from drifting apart. It is a local community of light, a gathering of kin in the vast, cold emptiness of the intergalactic medium. The local group is a small, sheltered cove where the water remains still, while the open ocean rushes away, a place where the history of the cosmos is written in the orbits of its members. It is a circle of friends holding hands in the middle of a gathering storm, refusing to be pulled apart by the wind. It is a handful of marbles resting in a single depression on a heavy woolen blanket, forever rolling toward the same center. It is a quiet conversation between giants in a room where everyone else is shouting and running for the exits, a shared secret whispered across the light years. It is a handful of colorful petals floating in a whirlpool, spinning together even as the current pulls everything else toward the horizon. It is a constellation of lanterns carried by a group of pilgrims, keeping the darkness at bay through their collective glow, drifting deeper into the structural elegance of the void. We witness the emergence of the great aggregations, the metropolitan hubs where the individual voices of galaxies merge into a grand gravitational symphony. These are the galaxy clusters, the largest gravitationally bound structures in the universe, where thousands of star systems are held in a permanent embrace. We look first toward the Virgo cluster, our closest neighbor in the celestial hierarchy. It is a sprawling urban center of over 1,300 members, centered around the colossal elliptical galaxy M87. This giant, a silent sovereign at the heart of the cluster, anchors the entire assembly with its immense mass, while a jet of plasma screams from its central black hole, a beacon marking the center of our local cosmic neighborhood. The Virgo cluster is not merely a collection of stars. It is the gravitational anchor for the local supercluster, the very ground upon which our own Milky Way finds its footing. It is a cluster of grapes ripening on a single ancient vine, each fruit a galaxy pulsing with its own internal life, yet inextricably linked to the branch. Further still, across the vast plains of space, lies the Coma cluster, dense and spherical gathering of more than 1,000 galaxies. Here, the density of light is so great that individual identities begin to blur into a singular glowing entity. It was here that Fritz Zwicky first noticed a strange discrepancy. The galaxies were moving too fast, as if held by a weight he could not see. This was the first whisper of dark matter, the hidden foundation upon which these cities are built. Between these galaxies lies the intracluster, medium, a sea of plasma heated to tens of millions of degrees, glowing with X-rays that remain invisible to our eyes, but fill the void with a restless, energetic warmth. This gas contains more mass than all the stars in the galaxies combined. Hidden ocean in which the island universes swim. The coma cluster is a parliament of owls gathered in a single ancient oak, their collective gaze fixed upon the center of a world we are only beginning to understand. It is a vast sanctuary of plasma where the walls are made of heat and the pillars are forged from the very fabric of space-time. It is a cosmic terminal at the end of a long, lonely road where the commerce of the cosmos is conducted in the currency of gravity. It is a hive of silver bees swarming around a central, unseen queen, their orbits tracing the lines of a magnetic field we can only map through its effects. It is a shimmering silk shroud draped over the shoulders of the universe, its folds hiding the secrets of the dark matter that gives it shape. It is a grand reunion of long-lost siblings, finally finding one another in the dark and refusing to ever let go, drifting deeper into the architecture of the immense. We find that the clusters we once thought were the pinnacle of organization are merely small provinces in a much grander empire. In the late 20th century, astronomers began to map the velocities of thousands of galaxies, noticing they were not just moving with the general expansion of the universe, but were being drawn toward a specific hidden destination. This led to the identification of Laniakea, name derived from Hawaiian meaning immeasurable heaven. It is a structure of such staggering proportions that it encompasses our Milky Way, the Andromeda Galaxy, and over 100,000 other island universes across a span of 500 million light-years. Within this vast domain, everything is bound by a shared destiny, a collective slide toward a mysterious focal point known as the Great Attractor. This region, partially obscured by the thick dust of our own galactic plane in the zone of avoidance, exerts a gravitational pull so colossal it bends the paths of entire clusters, acting as the gravitational heart of our local cosmic neighborhood. The technical reality of a supercluster is defined not just by proximity, but by the direction of flow. Scientists use the concept of a watershed to define these boundaries, just as every drop of rain on one side of a mountain ridge flows toward the same river. Every galaxy within Laniakea is part of a gravitational basin that moves toward the Great Attractor. This attractor is not a single celestial object like a black hole, but a massive concentration of matter, a gravitational valley so deep that it influences movement across hundreds of millions of light years. We are currently part of this slow motion migration, cosmic drift that defines the outer limits of our celestial home. Beyond these boundaries, other superclusters like Perseus Pisces or the Shapley concentration exert their own influence, drawing their own inhabitants toward different centers of mass. It is a colossal leaf fallen from an ancient tree where the galaxies are, microscopic organisms traveling along the intricate, branching veins toward the central stem. It is a vast, invisible basin carved into the bedrock of space-time, where the celestial waters move with a quiet, relentless determination toward a single, hidden drain. It is a grand map of migration, where the paths of a billion stars are traced in the ink of gravity upon a parchment of dark matter. It is a majestic delta where the rivers of light from 1,000 clusters converge before spilling into the ocean of the infinite. It is a giant silver spiderweb stretched across a canyon, vibrating with the weight of caught suns, all swaying toward the center of the silk. It is a cosmic lung, slowly drawing in the breath of the surrounding void, concentrating the essence of existence into a single, dense heartbeat. It is a master clock where the gears are made of galaxies, all turning in synchronized submission to a central, unseen spring. Letting this knowledge settle, we begin to see that these continents of light are but the individual fibers of an even more complex and interconnected reality. Letting this knowledge settle, we begin to see that these continents of light are but the individual fibers of an even more complex and interconnected reality. We perceive the architecture of the ultimate scale, a structure that dwarfs the galaxies it contains. In the earliest moments, the universe was not a smooth expanse, but a landscape of subtle textures, ripples in the dark, matter that acted as gravitational wells. Over billions of years, these ripples sharpened into a vast three-dimensional network known as the cosmic web. It is the skeletal system of the cosmos, where baryonic matter, the gas, and stars we can see, is funneled along invisible highways of dark matter. This web is composed of three primary features: the vast, flat sheets of matter, the long, spindly filaments that stretch across millions of light years, and the dense nodes where these threads intersect. Each node is a bustling metropolis of galaxy clusters, while the filaments act as the arterial roads, channeling fresh gas into the heart of these stellar cities. This is not a random scattering, but a precise geometric arrangement dictated by the fundamental laws of attraction. It is a lace curtain hung across the windows of eternity, its patterns revealed only by the starlight caught in its threads. It is the neural architecture of a slumbering giant where every synapse is a galaxy, and every thought takes an eon to travel from one end to the other. It is a delicate skeletal leaf where the flesh has withered away to reveal the sturdy, intricate veins that once carried the lifeblood of the universe. It is an expansive irrigation system carved into the bedrock of space, ensuring that the nectar of hydrogen reaches the thirsty gardens of the clusters. It is a coral reef of gravity, built layer by layer in the dark, providing a home for the vibrant life of a billion suns. It is a network of mountain ridges rising above a fog-filled valley, connecting peaks of light across a distance that defies the imagination. It is the intricate geometry of a dragonfly's wing, scaled up to the size of the infinite, vibrating with the energy of the vacuum. As we gaze upon this grand design, we notice that the web defines not only where matter exists, but also where it does not, leading our eyes toward the immense, silent stretches of emptiness that lie between the threads. Letting this knowledge settle, we turn our gaze away from the crowded highways of light and toward the vast, hushed expanses that define the negative space of the cosmos. In 1981, as astronomers began to draft the first true maps of the larger scale universe, they encountered a silence so profound it challenged their understanding of the grand design. In the direction of the constellation Boötes, they found a region of space so devoid of matter. It was dubbed the Great Nothing. This was the first glimpse into the cosmic voids, the immense spherical or polyhedral bubbles that make up the majority of the universe's volume, while the cosmic web is the bone and sinew of the universe. These voids are the breath between words, the stillness that gives the structure its shape. Technically, these voids are not entirely empty, but their density is significantly lower than the average. The Boötes void spans nearly 330 million light years in diameter, representing a staggering 2% of the observable universe's diameter. Within this colossal sphere, one might expect to find thousands of galaxies, yet we have observed fewer than 100. If our own Milky Way were positioned at the center of this emptiness, we would have looked out into a black, featureless sky for centuries, unaware that a wider universe even existed beyond our lonely isolation. These regions are the result of a cosmic tugaphore. As gravity pulls matter toward the dense filaments and clusters, it effectively evacuates these pockets, causing them to expand like rising bubbles in a thick dough. This process, often called the void push, means the voids themselves exert a kind of repulsive influence, driving the evolution of the cosmic web. By pushing the threads further apart, it is a vast clearing in a forest of stars where the wind never blows and the ground is made of pure shadow. It is a hollow glass bead hidden within a mountain of granite, preserving a perfect, undisturbed vacuum. It is the wide, smooth surface of a frozen pond where no skaters have ever left a mark, reflecting only the distant, unreachable glow of the shore. It is a quiet room at the heart of a bustling city where the walls are so thick that the roar of traffic is reduced to a memory. It is the space between the ribs of a giant protecting a heart of absolute stillness. It is a desert of such purity that even the dunes are made of lightless air, stretching toward a horizon that never ends. As we contemplate these great absences, we realize that the universe is not just a collection of things, but a delicate balance between the presence of light and the majesty of the nothingness that holds it. Drifting deeper into the architecture of the cosmic web, we begin to see that motion is not merely matter of attraction. For decades, astronomers watched our local group of galaxies hurtling through space toward the massive Shapley attractor, yet the math never quite balanced. The pull was strong, but the velocity was greater than the visible mass could justify. In 2017, a team of cosmologists looked not at where we were going, but at what we were leaving behind. They discovered a vast, empty region of space, a void of such profound underdensity that it acts as a cosmic counterweight. This is the dipole repeller, the silent partner in the dance of our galactic migration, providing the hidden push that matches the distant pull. To understand the dipole repeller is to understand the physics of absence in the fluid dynamics of the universe. A region with less matter than its surroundings exerts an effective repulsive force. It is not that the void contains a new kind of energy that actively shoves us away. Rather, it is the gravitational vacuum left by the lack of galaxies, while the Shapley attractor pulls us forward with the weight of thousands of galaxies. The dipole repeller creates a pressure from behind, a gradient of density that directs the flow of matter along the cosmic filaments. We are caught in a dipole flow, a grand stream of space-time, where we are simultaneously exhaled by the void and inhaled by the cluster. This discovery reshaped our map of the Laniakea supercluster, revealing that the great voids are just as influential as the great masses in determining the fate of every star. It is a silent mountain of air behind a traveler, urging them forward toward the valley's embrace. It is the invisible hand of a receding tide that clears the beach, making room for the next swell of the sea. It is a hollow flute through which the breath of the universe blows, creating a melody of motion without ever touching the strings. It is a mirror made of shadow that reflects the light away, ensuring that the currents of the cosmos never remain stagnant. It is the cold draft from an open door in a warm house, nudging the curtains toward the Hearth, it is the space behind a falling leaf where the air rushes in to fill the gap, driving the descent. It is a silent ghost, ship in a crowded harbor, clearing a path through the water simply by its refusal to be occupied. It is the absence of a footprint in the sand that tells the story of the winds. Direction, drifting deeper, we find that the void is not merely a theater for local dramas, but a canvas for structures so immense they defy the very scale of our imagination. Letting this knowledge settle, we turn our gaze toward the great cosmic walls, those massive filaments of matter that represent the largest known structures in the observable universe. In the early years of the 21st century, astronomers mapping the sky through the Sloan Digital Sky Survey uncovered a colossal arrangement of galaxies stretching over 1.3 billion light years across the deep night. This Sloan Great Wall was once thought to be the limit of cosmic organization, a vast continental shelf of light where the shallow seas of clusters meet the deep trenches of the true void. It is a mountain rain of suns whose peaks are so distant from one another that light itself grows old traveling between them. Yet, as our instruments peered further into the ancient past, an even more staggering titan emerged in 2013 by tracking the violent signatures of gamma bursts. Researchers identified the Hercules Corona Borealis Great Wall. This structure spans an inconceivable 10 billion light years, occupying more than 10% of the entire observable diameter of the universe. It is the ancient shoreline of a receding primordial ocean, a feature so large it challenges the very principle that the universe should look the same in every direction. At this scale, the cosmos reveals a texture that is far from smooth. It is a massive reef of galaxies built over eons by the slow accumulation of gravity's coral, a grand frozen tsunami of matter caught in the amber of spacetime. These walls are the heavy silver foundations of the cosmic house, providing a skeletal framework upon which the tapestry of the stars is hung. They represent a great winding river of light that flows across the entire span of the visible sky, the spine of a sleeping leviathan whose breath is the expansion of space itself. To look upon such a wall is to witness vast, luminous wall of fog marking the edge of a celestial continent, a boundary where the density of existence reaches its most profound expression. It is a colossal bridge of stars, spanning the distance between the known and the unknowable, a reminder that the universe organizes its thoughts on a scale that dwarfs our understanding of time and distance. These walls are the silent guardians of the largest scale structure, the ultimate testament to the patient, persistent pull of gravity over billions of years, weaving the scattered dust of the Big Bang. into a lattice of unimaginable grandeur, drifting deeper into the heart of our own celestial home. We find that even the most serenity structures hold memories of ancient violence and sudden spectacular awakening. For eons, the space above and below the Milky Way's disk appeared to be a silent, empty attic, a void untouched by the frantic energy of the spiral arms. Yet, beneath this mask of stillness, the galaxy was hiding its own history, a record of a time when the central black hole breathed fire into the darkness. These are the Fermi bubbles, gargantuan lobes of gamma-ray and X-ray emission that tower 25,000 light-years in either direction from the galactic core. They are like two iridescent dragonflies, wings emerging from the center of a cosmic flower, fragile in their transparency, yet immense in their physical reach. These structures were born from a singular, colossal event, perhaps a few million years ago, when the supermassive black hole at our center consumed a vast feast of gas, or when a sudden fever of star formation ignited the core. This outburst sent a shockwave of particles and radiation screaming into the halo, inflating these massive cavities like a pair of majestic, invisible lungs caught in mid-exhale. Technically, these bubbles are defined by their sharp, well-delineated boundaries, indicating a supersonic expansion that pushed aside the existing galactic medium. Within them, high-energy electrons collide with the ambient starlight, boosting those photons to the level of gamma rays through the process of inverse Compton scattering. This makes the bubbles glow with a spectral light that remained invisible to us until we had the eyes to see. In the highest energies, to look upon them is to witness ghostly hourglass carved from the very fabric of the high-energy vacuum, a temporal map of our galaxy's energetic past. They serve as a cosmic barometer, recording the intensity and duration of an outburst that would have rendered the galactic center a place of blinding, lethal brilliance, like twin violet plumes of smoke rising from a guttering candle. They persist long after the flame that created them has calmed, drifting in the quiet currents of the galactic halo. They remind us that the galaxy is a living, breathing entity, one that experiences cycles of dormancy and dramatic upheaval, leaving behind these luminous fossils as a testament to its restless spirit. They are the glowing embers of a campfire reflected in the morning dew of the deep cosmos, a lingering warmth that tells of a fire that once raged at the center of everything we know. Letting this knowledge settle, we drift toward the spectral presence of Hani's Vorwerp, a ghostly green smudge suspended in the void near the spiral galaxy IC 2497. This strange apparition, first noticed by a schoolteacher's curious eye during a grand census of the The stars serves as a profound reminder that the cosmos does not always exist in the immediate present. At first glance, it appears as a wisp of emerald light, formless cloud of gas that seems to glow with an inner fire, yet it contains no stars to provide such radiance. It is a cosmic anomaly, riddle written in the vibrant green of doubly ionized oxygen, indicating a level of energy that the neighboring galaxy, now calm and quiet, could not possibly generate in its current state. We are looking at a relic, a piece of celestial history that has been frozen in the act of transformation, a luminous fossil of a violent era. This ethereal glow is what astronomers call an ionization echo, a lingering scream from a dead quasar. In the recent cosmic past, perhaps only 100,000 years ago, the supermassive black hole at the heart of IC 2497 was a raging engine of light. It was a quasar, a brilliant beacon fueled by the violent consumption of infalling gas, radiating intense ultraviolet and X-ray light into the surrounding intergalactic space. This torrent of radiation struck a massive bridge of gas, a tidal tail pulled from a nearby galaxy during a slow-motion collision. This bridge acted as a canvas for the quasar's fury, with the high-energy photons stripping electrons from their atoms and leaving the gas in a state of high-energy agitation. Today, the quasar has exhausted its fuel and fallen into a deep slumber, yet the light from its final meal is still making its way across the tens of thousands of light years to the gas cloud. We are seeing a ghost, photographic negative of a power that no longer exists in the center of the galaxy. It is as if we are standing in a dark forest and seeing the reflection of a lightning bolt on a distant mountain peak long after the storm is past and the sky above us has returned to silence. These echoes are the footprints of a giant who has already left the room, the warmth remaining on a chair after the occupant has walked away. They are the cosmic equivalent of a sunset's afterglow caught on the underside of a high-altitude cloud where the sun has already dipped below the horizon for the observer on the ground, but its light still finds a way to touch the heights. The Vorwerp is a grand, luminescent ledger recording the history of a feast that ended eons ago, a green lantern held aloft by the memory of a light that has failed. It is a fluorescent bulb humming in the dark after the power has been cut, or the fragrance of incense that lingers in a cathedral long after the ceremony has concluded. A beautiful, haunting testament to the enduring reach of light across the ocean of time, drifting deeper into the emerald glow of the early cosmos. We encounter the Lyman alpha blobs, structures so vast they challenge our understanding of how matter first began to congregate. These are not mere galaxies, but immense cocoons of glowing hydrogen gas, stretching hundreds of thousands of light years across the void. First identified in the deep reaches of spacetime, they represent a period of profound transition where the first massive structures were condensing out of the primordial mist. The luminescence of these blobs originates from the Lyman alpha transition, a specific dance of the hydrogen atom where an electron falls from its second energy level to its lowest state, releasing a photon of ultraviolet light. In the expanding universe, this light is stretched into the visible spectrum, appearing to us as a ghostly, extended aura. These regions are often the birthplaces of massive galaxy clusters, fueled by the cooling of gas as it falls into dark matter wells, or agitated by the ferocious winds of newborn stars and the hunger of central black holes. Amidst these giants, we also find the green pea galaxies, small, compact anomalies discovered by the curious eyes of citizen scientists. These are dense nurseries of star formation characterized by an intense emission of doubly ionized oxygen that lends them their distinct verdant hue. Despite their small size, they are fierce, leaking high-energy radiation into their surroundings, serving as modern-day proxies for the ancient galaxies that once ended the cosmic dark ages by reionizing the intergalactic medium. A Lyman alpha blob is a luminous blanket of fog draped over a hidden bonfire where the light of 1,000 suns is softened and spread by the surrounding vapor until the entire sky seems to breathe with a pale, rhythmic glow. It is a vast, translucent jellyfish poolsing in the dark currents of the cosmic ocean, its long, glowing tendrils reaching out to touch the neighboring filaments of the cosmic web. The green pea galaxies, by contrast, are like emerald sparks flying from a blacksmith's anvil, small but intensely hot, carrying the concentrated energy of an entire era within their compact frames. They are the cosmic equivalent of a pressurized steam valve, venting the raw power of stellar birth into the cold silence of space. Each one is a vibrant seed of light, a concentrated drop of life-giving energy that refuses to be contained by the shadows of the deep, past a verdant bead of glass glowing with the intensity of 1,000 suns, signaling the end of the long night and the beginning of a universe defined by the brilliance of the stars, drifting deeper into the energetic pulse of the vacuum. We encounter the swiftest travelers the universe has ever known. For over a century, since the early pioneers of physics ascended into the thinning air to measure the invisible rain of the heavens, we have known that the cosmos is alive with motion. But among the steady stream of common particles, there exist rare, singular entities that defy the expected scales of reality. The ultra-high energy cosmic rays. These are not merely bits of matter, but solitary protons and atomic nuclei accelerated to velocities so extreme that they carry the kinetic energy of a professional tennis serve within a single subatomic speck. They are the microscopic bullets fired from a silent, invisible cannon crossing the gulfs between galaxies with a momentum that challenges our understanding of the celestial forges. In the quiet desert of Utah in 1991, one such traveler was captured, a particle so potent it was named for the disbelief it inspired. Yet, even these titans face a silent, invisible barrier in the dark. This is the GZK limit, a threshold where the very fabric of space becomes a thick, resistant medium as these particles journey across the void they must wade through. The pervasive sea of the cosmic microwave background, the ancient afterglow of the beginning of time. When a proton's energy reaches this staggering peak, it can no longer pass through this bath of low-energy light without consequence. Instead, it strikes the photons of the background radiation, sparking the creation of new particles and shedding its own energy in a process of cosmic friction. This interaction acts as a celestial sieve, ensuring that no traveler of such immense power can survive a journey from the most distant reaches of the cosmos. They are effectively barred from crossing the deepest abysses of time and space. Thus, when we detect these high-energy messengers, we know they are the products of our own local neighborhood, born, perhaps, within a few 100 million light years. They are like solitary travelers crossing a frozen tundra against a relentless headwind, their strength slowly sapped by the very air they breathe. They represent a phantom rider on a translucent horse, galloping through the night only to be slowed by the heavy cloak of light that permeates the universe. Each one is a master archer's arrow that refuses to fall until it strikes the invisible wall of the ancient past, a single vibrating string stretched across the width of a galaxy, humming with a frequency so high it threatens to snap against the resistance of the vacuum itself. They are the ultimate expression of kinetic grace, reminding us that even in the emptiest spaces, the universe possesses a subtle, limiting touch that keeps the infinite in check. Drifting deeper into the tapestry of the night, we find that the light we witnessed crossing the void eventually finds destination, striking the surfaces of worlds we once only dreamed of. For centuries, our own solar system was the only map we possessed. Familiar arrangement of rocky inner worlds and distant gas giants that we assumed was the universal standard. We viewed our 8 neighbors as the definitive architecture of existence, a singular template repeated across the stars. But the first ripples of discovery shattered this quiet assumption, revealing a reality far more chaotic and creative than our limited perspective allowed. Letting this knowledge settle, we recognize that the galaxy is a gallery of the unexpected. We find hot Jupiters, massive gas giants that orbit so close to their parent stars they complete, year in a mere matter of terrestrial days, their atmospheres scorched into a permanent, glowing gale. These giants defy our models of planetary formation, having migrated inward through the protoplanetary disk, pushing through the dust like heavy ships through a thick fog. Then there are the super-Earths and mini-Neptunes, worlds with masses between our home and the icy giants of our outer reaches. These are the most common planets in the Milky Way, yet they are entirely missing from our own Sun's family, existing as a bridge between the solid and the ethereal. Some are water, worlds where oceans hundreds of kilometers deep wrap around a core of exotic ice, while others are scorched lava worlds where the very rock rains down from the sky as molten glass. We even encounter rogue planets, dark wanderers that have been cast out of their home systems by gravitational skirmishes, traveling through the interstellar gloom without the warmth of a sun. These exoplanets are the master painter, discarded sketches, each one a bold experiment in what is possible when gravity and chemistry are left to play in the dark. They are a collection of mismatched keys for locks that have not yet been built. A hot Jupiter is like a great iron bell suspended inside roaring furnace, vibrating with the intensity of its proximity to the fire. A rogue planet is a silent traveler who has forgotten the language of light, walking through a city of shadows where the only heat is the memory of its own birth. The diversity of these systems reminds us that our own home is but one stanza in an epic poem that spans the diameter of the galaxy. It is as if the universe is a master jeweler who, having crafted a perfect diamond, decided to fill the rest of the vault with every uncut stone, every shard of glass, and every grain of sand, finding beauty in the sheer, unbridled variety of the collection. We are no longer the center of the story, but witnesses to an infinite library of worlds, each page turned by the slow, patient hand of time, drifting deeper into the gallery of the improbable. We find the boundaries between life and death, for a star becoming blurred, as if the universe were experimenting with the very definition of a celestial body. In the mid-1970s, the theoretical work of Kip Thorne and Anna Zitko introduced us to a hybrid that defied the standard rules of stellar evolution, a star existing within the heart of another. These Thorne-Zitko objects are the result of a cosmic intimacy gone wrong, occurring in binary systems where a neutron star is eventually swallowed by its larger, more bloated red supergiant companion. Instead of a violent explosion, the neutron star settles into the core of the giant, creating a stable but bizarre partnership. Technically, the energy that keeps this massive structure from collapsing is no longer the familiar nuclear fusion of hydrogen into helium. Instead, it is the gravity of the neutron star itself, pulling the surrounding gas onto its surface and releasing a torrent of energy. This process, known as accretion, creates a distinctive chemical signature, churning up elements like rubidium and molybdenum that should not exist in such abundance. It is a heavy lead weight hidden inside a giant crimson balloon, a pearl that has decided to grow inside a cloud of fire. This hybrid remains a grand, luminous shell protecting a secret of absolute density, a celestial nesting doll where the innermost figure is made of pure gravity, moving even further into the ancient reaches of time. We encounter the quasi-stars, the forgotten behemoths of the early universe. These hypothetical giants were born from the collapse of massive proto-galactic clouds, reaching masses thousands of times that of our sun. Their inner pressure was so great that the core would collapse directly into a black hole, while the outer envelope remained intact. For a few million years, the black hole would feast upon the star from the inside out, generating such immense radiation that it supported the star's massive bulk. Against its own weight, it was a massive glowing hive where the queen is, a shadow, a lantern where the flame is a doorway to nowhere. The quasi-star was a cathedral built around a storm, a roaring waterfall caught in a permanent upward spray. Eventually, the black hole would consume its host, leaving behind the seeds of the supermassive black holes that now anchor the centers of galaxies. These objects remind us that the architecture of the cosmos is not limited to the familiar, but includes hollow mountains of light and dark seeds that feed the very fruit that contains them. Letting this knowledge settle, we move from the scale of individual stars to the scale of everything that could possibly exist, contemplating the architecture of the cosmos and the distant horizons of its eventual end. Theoretical cosmology suggests that our visible universe might be but a single bubble in a foaming sea of infinite realities. This multiverse hypothesis arises from the mathematics of eternal inflation, where the vacuum continues to expand forever, occasionally calving off pockets of space where the expansion slows and the laws of physics take hold. In some of these bubbles, the constants may be so different that light cannot travel or atoms cannot form, making our own existence a rare and quiet miracle. This sense of delicate balance is known as fine-tuning, the observation that if the strength of gravity or the mass of an electron were altered by even a fraction, the stars would never have ignited. It is like a master gardener adjusting the pH of the soil to a single decimal point to ensure a rare orchid can bloom in a desert. To explain this precision, some look to the holographic principle, the mind-bending realization that all the three-dimensional information of our world might be encoded on a two-dimensional surface at the very edge of the universe, like the image on a silver coin that contains the depth of a whole landscape. The reality we touch and breathe may be a projection of a flatter, more fundamental truth. Evidence for these vast ideas hides in the subtle bruises of the cosmic microwave background, cold spots that defy standard explanation and may be the literal fingerprints of other universes pressing against our own. We now listen to these secrets through gravitational waves, the hum of a distant highway, heard through the floorboards of an old house, carrying the echoes of the first moments of time. Yet every grand narrative has a final chapter, and for the universe, this is the thermodynamic endgame. As the expansion of space accelerates, galaxies will drift so far apart that they disappear from each other's sight, leaving every island of stars in total isolation. Entropy, the measure of disorder, will continue to rise until the last black hole has evaporated into a thin mist of radiation. This leads to the heat death, a state of perfect, unchanging equilibrium, where no more work can be performed and no more light can be shed. It is a grand ballroom where the last candle has sputtered out and the dancers have all gone home to sleep, a cup of tea that has reached the exact temperature of the room. In this final stillness, the universe finds its ultimate rest, a silence that is not an absence, but the completion of every possible song